Hi, Sophie. So I'm just going to go over the couple of questions from the Chapter 14 workbook. So the first one was number 3, and we were looking at an aqueous solution of nickel 2 chloride being electrolyzed, and you pointed out like a bunch of things that I think, I don't know, honestly, it just seems like they pretty much messed up everything in this solution. Because I've gone to like multiple other sources and every other source confirmed that, because I got like 1.62, I think it was, and every other source confirmed that that was accurate. So this answer, the answer that they gave in the solution there, was incorrect. So really quickly, I'll just walk you through the question in case you need that as well. So we're looking at a solution of nickel 2 chloride being electrolyzed. So we have Ni2 plus, Cl minus, and water as our entities. And if we go through our chart here, we find nickel 2 plus, where did I see that? Nickel 2 plus is here. So as an oxidizing agent, it's above water. So that's going to be our SOA. And then for chloride ion, it's up here. And remember that we're following the chloride anomaly. So even though water is lower than it on the chart, we still use the chloride ion as our SRA. So we have SOA and SRA. And so then we just want to keep in mind that our SRA is going to be at the anode, so we can write our half reactions. So at the anode we have 2 chlorine ions going to make Cl2 plus 2 electrons. And that has an electric potential of plus 1.36. And then at our cathode, we have our SOA. So we want to write the reduction half reaction there, which was, sorry, I just got to find it on the chart here, nickel 2 plus. Plus 2 electrons forming solid nickel. I didn't worry about the states in here. Okay, so then we can write our full reaction from that. So we have 2 chloride ions plus our nickel ion. And of course our electrons are going to cancel out. So then on our product side we have chlorine and nickel. Okay, so I wasn't super careful there with my states and everything, but that should be our basic idea there. Oh, I forgot to put in, so nickel is going to be negative 0.26. And the last thing they wanted was for us to calculate the minimum electrical potential difference. So just remembering, because we're in an electrolytic cell, that always has to be a negative value. And our formula for that is cathode minus anode, right? So E naught for the cell is the electric potential of the cathode, so negative 0.26, minus the potential of the anode, so 1.36, and that gave me negative 1.62. So yeah, even the value they had there as negative 1.10 is incorrect. So like you mentioned, let me just see what you wrote here. Yeah, like, I mean, I feel like they kind of flipped around everything. The equations were flipped. The charges were flipped as well. So just ignore the solution they had in there, and hopefully this is probably what you worked out for yourself as well, and that would be the correct answer for that one. Okay, the next question you had was on page 5 of the same booklet, if I understood what you were saying correctly. You said slide, so I looked in the notes, but I think you meant page. Sorry, I can't find the question now. Oh, okay, so it's number booklet 3, slide, page 5, number 2. Okay. So in this one, I can pull it over here a second. Or maybe I can't because my computer's being super glitchy. So in this one, it's determining the mass of chlorine produced when you have a certain amp of current flowing for 24 hours through a cell containing molten sodium chloride. And we're wondering at which electrode is the chlorine produced. So you were basically just asking how do you know which electrode it would be at. So basically all you want to do in there is just remember there was a slide in the notes that kind of went over the fact that if you have mass being produced, then the element should be the product. And in this particular question, it asks you to determine the mass of chlorine that was produced. So if we go to our table, we know that that is going to be this reaction here. And in order for chlorine to be produced, we need to be looking at the oxidation half reaction, so the reaction in reverse, basically. And so if that's true, then if we're dealing with oxidation, so basically, I'll just write down a couple things. So if we have mass produced, then we have to look for the element, like the reaction that produces the element. Reaction producing element. And so in this case, the reaction that we find on our chart is 2Cl minus going to make Cl2 plus 2 electrons. And so that's an oxidation half reaction. And so then all you have to remember is that oxidation occurs at the anode. And so that's where this reaction would be taking place. Okay, so that's all you need to know to solve those kinds of problems. Hopefully that helped. Sorry for the delay in the response, and let me know if you have any further questions.